In the vast expanse of the ocean, sharks reign as enigmatic rulers, finely tuned by evolution for a life of predation. Among their remarkable sensory adaptations, their extraordinary sense of hearing stands out, transcending the conventional understanding of this aquatic marvel. This exploration delves into the intricate details of how sharks, particularly species like the lemon shark, harness their incredible sense of hearing and electroreception to navigate the depths, locate prey, and maintain their status as apex predators. Sharks, including the lemon shark, boast a sophisticated auditory system, finely crafted by millions of years of evolution. Their ears, concealed beneath the skin, are not visible externally like those of mammals. Instead, they are intricately embedded within the skull, allowing sharks to detect a diverse range of sounds in their aquatic environment. The auditory system of sharks comprises a set of fluid-filled canals and specialized hair cells known as ciliary cells. These canals are connected to small openings on the shark's head, known as spiracles, which facilitate water flow over the gills. This design allows sharks to perceive subtle changes in water pressure caused by sound waves, converting them into neural signals that the brain interprets as sound. The lemon shark, in particular, possesses a highly developed auditory system, enabling it to detect a broad spectrum of frequencies. This acute sense of hearing is a critical tool in the shark's arsenal, aiding in tasks ranging from locating potential prey to navigating complex underwater environments. While the auditory prowess of sharks is impressive, it is their electroreception ability that elevates them to a level of sensory mastery. Electroreception involves the detection of electrical fields, and some shark species, including the lemon shark, have perfected this technique to an astonishing degree. The secret lies in specialized organs known as the ampullae of Lorenzini, named after the 17th century Italian scientist who first described them. These ampullae are distributed across the shark's head, forming a network of gel-filled canals connected to pores on the skin's surface. Within these canals, there are jelly-filled tubules leading to the ampullae, each containing sensory cells. The ampullae of Lorenzini are exquisitely sensitive to electrical fields, allowing sharks to perceive the minute electrical impulses generated by living organisms, including the rhythmic pulses of a beating heart. This electroreception ability is particularly well developed in species like the lemon shark, granting them a unique and unparalleled advantage in their marine environment. Sharks, being ambush predators and often dwelling in environments with limited visibility, rely on their acute sense of hearing and electroreception to navigate and locate prey. The combination of these sensory abilities creates a comprehensive and efficient system for sharks to thrive in the vast and often challenging underwater realms. The lemon shark, armed with its advanced auditory system and electroreception capabilities, employs various hunting strategies. In murky waters or during low-light conditions, where vision may be compromised, the shark can rely on its acute hearing to detect the sounds associated with prey movement or struggling. Sharks, including the lemon shark, are renowned for their ambush tactics. By detecting the electrical fields generated by the muscle contractions and heartbeats of potential prey, they can pinpoint their target even when concealed in the shadows. This enables the shark to launch swift and precise attacks, minimizing the chances of prey escape. Sharks use their sense of hearing and electroreception not only for hunting but also for navigating their surroundings. The underwater world is teeming with a cacophony of sounds, from the subtle clicks of crustaceans to the distant movements of larger marine creatures. The lemon shark, attuned to these auditory cues, can navigate through complex environments with remarkable precision. The evolution of such sophisticated sensory mechanisms in sharks, including the lemon shark, is a testament to their resilience and success as apex predators. Over millions of years, these creatures have adapted and perfected their abilities to survive in diverse marine ecosystems, showcasing the intricate dance between evolutionary forces and the demands of their environment. The combination of acute hearing and electroreception positions sharks as masters of predation. This sensory prowess enables them to efficiently locate, track, and capture prey, contributing to their role as top-tier predators in the oceanic food chain. The lemon shark's advanced sensory systems allow it to adapt to a range of environments, from shallow coastal waters to deeper offshore regions. This adaptability is crucial for the survival of the species, enabling it to exploit various ecological niches and respond to changing environmental conditions. Understanding the intricacies of sharks' sensory mechanisms, such as those found in the lemon shark, is not merely a scientific curiosity, it has significant implications for conservation efforts. As apex predators, sharks play a crucial role in maintaining the health and balance of marine ecosystems. Preserving their habitats and mitigating anthropogenic threats are essential for ensuring the continued existence of these extraordinary creatures. Human activities, including overfishing, habitat degradation, and pollution, pose significant threats to shark populations. These anthropogenic pressures can disrupt the delicate balance of marine ecosystems, affecting not only sharks but also the myriad species that depend on these apex predators. Conservation initiatives aimed at protecting shark habitats, implementing sustainable fishing practices, and raising awareness about the importance of these apex predators are critical. By safeguarding the environments where sharks, including the lemon shark, thrive, we contribute to the preservation of the intricate symphony of the seas. In the grandeur of the ocean's depths, the lemon shark and its fellow denizens represent a testament to the marvels of evolutionary adaptation. Their sophisticated auditory and electroreception capabilities paint a vivid picture of the ongoing symphony beneath the waves, where sharks navigate, hunt, and contribute to the intricate balance of marine life.